On today's episode, it's Deep Impact. We're going to hit something. It's going to be fun. I'm Paul, the pressure-fed astronaut, and coming in from Waterworld, who are you?
I'm a man who just survived 2 hurricanes. I'm face of Sarcasm.
Yeah, so you're calling in from your trimaran.
Yeah, yep. Coming in live from the beautiful waters of, I guess, either the North Atlantic or the Gulf of Mexico. I don't really know which one's the water.
It's the Florida Sea. That's what it would be called.
Got it, yeah.
Yeah, you're on your trimaran. I'm on an atoll, Gotta watch out for Dennis Hopper.
But I do have paper.
Yeah, you got dirt, though?
Ooh, yeah, got some dirt.
Yeah, good. Yeah, because, as I said, nothing's free in Waterworld. For those of you who don't know, Waterworld is a movie that is old as I am, with Kevin Costner. I also really like Waterworld. Now, when I say this, I'm going to add the caveat, though. Not the theatrical cut. You got to get the full one, okay? The long version, the TV version, which unfortunately has TV swears in it, but it's better because there's more going on. You got to get that version of it, okay? The 3-hour one. It's Mad Max on jet skis. What are we talking about today?
We're talking. Well, it looks like we're talking about some Deep Impact, right? We're going to be slugging some big rocks out in space.
Yeah. I'm going to slug Tail Yoni out into space. Wait, no, that's the Christmas special.
What?
Because these are both coming out in December.
Oh, yeah, okay.
Yeah. It's October when we're recording this. Again, because Milton just,
Milton just did its thing.
So, yep, so this is the Deep Impact mission, which came after the movie.
Great.
Yeah. So to start, I guess we're going to start this with the question. Asteroids and comets they're interesting, right? We've done some flybys at this point. It's the mid-90s. We've done a few asteroid flybys. And comet flybys, right? 1986.
Yeah.
But that's only the surface of them.
Mm-hmm.
What's inside?
I assume more of, like, the surface, but, like, dark and cramped.
Yeah. How do you know, though?
I'm just guessing. You have to go find out, right?
And how would you do that?
Well, you send, you let give Michael Bay a lot of money, and then he just flies up the shuttles like, jet fighters, and then you get a bunch of people to drill into them.
That's pretty close, yeah. Or you hit it really fast.
Oh, or that.
So one of the things that was discovered during the Halley's Comet flybys in the 1980s was the surface is actually a lot darker than they thought.
Really?
Yeah, because it's a bunch of water ice coming off, right? It's a comet, right? But the surface is kind of dark. What's going on? What's going on inside a comet?
Okay. Stuff?
Exactly. Now, the theory for how comets work is the dirty snowball theory, proposed by, I think, Frank or Fred Whipple, which is it's a snowball with dirt in it.
Dirty snowball.
Yeah, kind of like we're from Minnesota, right? We know what those are like.
Yeah.
So how do you get to the inside of a comet? Well, easy. You blow a section of it off, right? You hit it fast enough, stuff will come out.
Yeah.
Now, the original proposal was to launch a spacecraft at the comet Phaeton, it's called, in the mid-90s and hit it at 33,000 miles an hour.
Oh my gosh.
Now, some other scientists said, this is a good idea, but you got to scope it back to a Discovery class mission, right? Certain budget size. You can still do it, though, right? It's just, wait, you have this idea, now make it something you can do.
Right. Okay.
So the team, now the other question, sorry, I forgot to include this, was, could you actually do this, right?
Could you actually smack and slug an asteroid or a comet?
Yeah. Can you hit it? Could you launch an impactor to hit this thing?
Yeah. I imagine you can.
Well, to prove you can, you saw the first picture. So in 1996, the first proposal is given, because for these missions, you have to come up with a proposal, right? It's a selection process, a contest, right? Which probe should NASA give money to go do things? And these are called Discovery class missions. There's Flagship class, right? Explorer class, right? It's the scale and scope of them is, Flagship, of course, the big ones like Mars rovers, the Titan helicopter. That's a Flagship class mission because it's really expensive. But these are kind of the mid-budget missions.
Okay.
So And so this was proposed in 96 and 98. It's called Deep Impact. I don't know how it got its name. I'm going to assume it got the name for what they're going to do, which is a deep impact. But I think the movie helped. Because again, 96, 98. Movie comes out in 98.
Yeah. What comes out that year?
So it's down selected as the 8th Discovery class mission and confirmed in May 2000. So the target is they're going to launch this in January 2004 with a deep impact on July 4th, 2005. You know what the other mission selected as a Discovery class in this round was?
What?
Messenger, the next space probe I'm doing.
Oh,
Yeah.
nice. Okay.
It's nice. Yeah.
Ties it all together.
So that's what they're going to do, right? They're going to build a small, again, it's going to go on a Delta too, okay? Right? Contour was a Discovery class mission.
Okay.
Right? It's one of those kinds of missions. I think Deep Space One was a Discovery class. Right, it's a classification of mission. We should do a video on that to discuss the different classifications of missions.
Probably should, yeah.
Because again, flagship, of course, it's the expensive one. It's the Mars rovers.
It's the flagship.
Yeah. So this is Deep Impact. It's a weird looking guy.
Mm-hmm.
It really is. We're going to see more pictures of it later. It's a pentagonal spacecraft bus, and it's actually 2 spacecraft.
Really?
So up top here, the solar panel antenna, not a gun. That's a camera.
Cannon. The cannon. That's what they're going to shoot the asteroid with. Huh?
Yeah. So it's a flyby spacecraft that's going to do all the maneuvering, all the fun stuff. It weighs about 1,300 pounds. It's got some maneuvering propellant, and it's got a big 9x9 solar panel.
Nice and big.
Yeah.
9 what?
Feet.
Oh, okay.
Yeah. 9 feet. Or 2.8 meters if you want to be, metric.
I don't want to be that.
So on board this... Oh, so... Okay, sorry, I had to get back to this. On the bottom is the impactor. That's the thing that's going to hit the comet.
Oh, okay.
At greater than 10 kilometers a second, which is about 23,000 miles an hour.
Nice.
So for reference, the ISS orbits the Earth at about 18,500 miles an hour, right?
Jeez. So it's going to be cooking.
They're going to hit this thing. So the impactor, of course, is going to hit the comet. The flyby spacecraft is going to take pictures of it, right?
Okay.
Right. It's your friend on the Facebook Live or whatever, right? Get into a fight. Come on, go do that. Yeah. Ooh.
World star.
Yeah, World Star. Actually, World Star was around at this time, so yeah.
Yeah.
So it's going to do a flyby of about 500 kilometers or 311 miles. So it's going to get really close as they're going to hit it.
Mm-hmm.
So there's 2 experiments on board the flyby spacecraft.
Okay.
We have the high-resolution instrument. It's
not a cannon.
It's not a cannon. It's not even made by Canon. It's a giant camera. It's going to take pictures.
Okay.
So it's a 30-centimeter, 11.8-inch diameter telescope that directs light into a multispectral camera and infrared spectrometer. Right? They're going to hit this thing, and light's going to go through the dust. So to see what's coming out of it, right? Is the surface different than the interior?
Okay, yeah.
Right?
Get that basic spectroscopy stuff.
Yeah. And what's coming off it? We're going to see. We're actually going to see differences. It's going to be cool.
Ooh, okay.
Yeah. I got. There's actually a really helpful slideshow that's linked in the description that tells you the basic results from this, which I used as my primary reference. Please don't H-bomber guy me, okay? Okay, don't do that. So the resolution. So it's a multispectral. Of course, you want to see different things like water, CO2, silicates. What the comet's made of.
Yeah.
So at 700 kilometers or 420 miles, the resolution's about 2 meters per pixel.
Okay.
So I could fit in a pixel. It'd see me.
Yeah.
Sort of.
Okay.
I'd be a splotch.
You'd be a fuzzy pixel.
Yeah. So the other one is the medium resolution instrument. This one is about half the size. It's a wide field of view. So this is more like this is a big panoramic camera that'll image the comet and impact in full, and it'll actually help with navigation during the impact phase.
Okay.
So at the closest, the resolution's about 10 meters per pixel.
All right.
So it's more of a wide range. The big one, you can see a lot more. And this is it.
That's actually surprisingly high resolution given the difference.
Yeah. Hey, you can see. Wait, these are the different lenses for the multispectral stuff. Right? See, there's right. There's little circles there. You can kind of see it.
Kinda, yeah.
Yeah. And so these are actual pieces of equipment being inspected. right?
Oh, okay. I see. So that's a wheel. I thought that was a jumble of cables. That's a wheel.
That's
All
a
right.
wheel, yeah.
Dang.
This is the jumble of cables right there, see?
Okay.
Yeah.
Wow.
So then we have the impactor. This weighs about 820 pounds, about 372 kilograms. It's got some maneuvering propellant in it, so you can see there's little thrusters there.
Mm-hmm.
Right? This thing's about 3 feet wide.
Yeah, I see the image with the guy there for scale.
Yeah, so that's it. That's the actual thing.
Wow.
So the main mass of this is about 250 pounds of cratering material, which is copper. They're just going to hit this thing with copper really fast.
So instead of brass knuckles, it's copper
Yeah,
knuckles.
because the copper, if it shows up in the spectrum coming out of it, they'll know that's the impactor, because the comet shouldn't have copper on it.
Ah, okay.
See, just our luck.
You
Right,
hit
you
a copper
Yeah.
comet.
Yeah, it's a Bronze Age comet. They went up there.
Find some stone tools.
Yeah,
and stuff,
what's
or
going
just-
on? So it's got a camera on it. It's basically the same as the medium resolution one. So it's right here at the bottom. So this part, this is up, right? This attaches to the flyby module, but this is the part that's going to actually hit it first.
Okay.
Right.
So for the reference image, the bottom is what's smacking into it.
Yeah. Well, I mean, the whole thing's going in, but yeah.
Right. That's the direction that's going in.
Yeah. So you can see the camera peeking out the bottom there. It's basically the same as the medium resolution camera.
Mhm.
That's going to go hit it. And so it's going to use that for navigation to hit the comet.
Nice.
It's actually going to direct itself in and hit it. So this will operate for about a day before actually, after separating from the spacecraft and hitting the comet, right? Because they're going to set up the flyby so it takes pictures of the impact. And this
Got it.
hits it.
Okay.
Also on board is a CD that has 625,000 names on it.
Why?
It's a outreach program, right? You can
Okay.
send your name to the moon, send your name to... My name went to the asteroid Bennu. It's on OSIRIS-REx right now. You can do this. Yeah. I think you can send your name on Europa Clipper. Well, it's too late now. By the time you're hearing this, Europa Clipper is hopefully on the way to Jupiter.
Yeah.
It's launching in 2 days for us, so...
At time of recording, yeah.
Yeah. So this is actually the inside of it. This is what it looks like on the inside.
Messy.
A lot of wires.
A whole lot of wires.
It's... Thank goodness I'm not an electrical engineer.
Look at this nightmare.
Yeah, I mean, look at all of this. I don't even know what any of these do. There's equipment. It's probably all navigation and stuff, but,
Yeah,
spacecraft
there's white boxes and there's white cables coming out of it with orange tape. That's my extensive analysis of the electrical engineering of the spacecraft.
Yeah. Also, Cassini has a CD on it with all the names.
Oh, cool.
Yeah, again, it's an outreach thing, right? Hey, send your name to a comet.
Huh.
Yeah. It's outreach. It's so people know what's going on in our public space program. This is what your money's going to, guys. We're bombing comets.
Yeah.
All right, so here it is in the clean room being built. So you can get a good reference of what it looks like, the size of the thing.
Yeah.
It's a weird-looking spacecraft. I'm just going to say that. It just looks weird. I'm used to boxes or hexagons, This is...
Yeah. It's a pentagon with a hexagon, like solar panel and a cannon on the back.
Yeah, and it folds out, actually, the solar panel. It folds into place. You'll see it when it's... Oh, no, you won't see it. The camera's on board. Don't look at it.
The camera's on the other side. It's looking away.
These big guys here.
Yeah.
So you can see it, big camera and different people stacking onto the Star 48 motor there. So these are actually the springs that hold it on.
Oh, wow.
Yeah, that's what pushes it away. So yeah, there's some aerospace engineering for you. Springs push it away. And there's the camera, of course, at the bottom for navigation.
Right.
So you can see how it's all built and what it really looks like, all the insulation and things.
Yeah.
So here it is again, being loaded. This is actually at the pad. They're putting it on there, which if you take the early launches or early Cape Canaveral tour at Kennedy Space Center, this is right by the Air Force Missile Museum. We were there because you saw the pads.
Right, okay.
Yeah. So this is what it looks like again. Here it is. Here it is in the payload fairing of the Delta II.
Nice.
Yeah. It's a neat little spacecraft.
Yeah.
So here's the Delta II being built. Of course, I gotta get rocket stacking. I like Delta II. Okay, it's a nice looking rocket.
It's blue.
It's blue-green. It is blue,
Yep.
by the way. Officially, it is blue. Tori Bruno has confirmed it is blue. He even said what the hex code was, which I forgot.
Though it's a hex code.
Yeah.
It's blue with a lot of green mixed in.
Yeah. It's a nice looking rocket. And you can see the different stages, of course, being stacked, how small it is.
Mm-hmm.
Of course, everyone's wearing their hard hats because that's important because you have, rocket parts.
It's very tall.
Yeah.
Very big rocket parts. If that falls on your head, fortunately you're going to have your helmet there to
It's gonna
save you.
The helmet will protect you. Yes, if a solid rocket motor fell on you.
Yeah.
I'm going to tell you. So during Titan IV development, someone was actually killed because a Titan IV rocket motor segment fell on him and then exploded.
Oh, jeez.
Yeah.
Was the falling or the explosion that...
Does it matter?
No, probably not. Okay.
Yeah. So on a lighter note, so the initial launch plan is in January 2004. They'd have an Earth flyby, and then you'd hit the comet on July 4th, 2005.
Okay.
This would allow for them to basically get the spacecraft working and check out orbital, all that fun stuff. But there's an opening in 2005 for this impact. And
Okay.
I don't know why it got delayed to 2005, but it launches in January 2005. I couldn't find
Jeez.
anything on the delays. I know there was a delay because some of the electronics on the Delta K were a bit cracked. I found the report for that, by the way. I read through them and this is all vaguely familiar. I do repairs too. It's geez. So it's going to launch on January 12th, 2005 at 1:47 p.m. Eastern Standard Time.
Okay.
Yep. The launch vehicle is a Delta II. As you can see, it's the Discovery class launcher. It's all of them.
Mm-hmm.
Slick 17B, Cape Canaveral. Yep. Oh, here we go. So the launch is relatively uneventful.
Wow.
Yep. It goes into a parking orbit for a bit, then the PAM-D, which is a star 48, places deep impact into a heliocentric orbit to go hit the comet.
Okay.
Almost immediately after separation, deep impact goes into safe mode.
Oh, no.
They found it to be an incorrect temperature limit on one of the RCS thrusters for the catalyst beds for those.
Oh.
Yeah, it was one little error. It's like, safe mode. So again, because remember, this thing's tumbling, they spin it up to keep it more accurate. So you need the RCS to slow it down. So then they do that, they detumble it, and then on February 11th, the first trajectory correction maneuver is performed, and it's actually so accurate they don't need to do another one.
Oh, nice.
Yep. So, deep impact is on the cruise phase to Temple 1.
Okay.
So, the cruise phase is pretty much it's just, Earth impact.
Yeah.
The one problem with doing Discovery class missions at this point is everyone's using like Microsoft Paint to make their slides and their charts, and it's all stuff from the early 2000s, so it's very primitive.
Great.
This image I used is like white. This orbits are blue. It's just terrible looking. I had to say that, okay?
Okay.
They're all just really old. Again, it's just a weird point where you don't have the 80s stuff where it looks really cool, all official, and now it's all better because we know what graphic design is. It's in that weird spot.
Where it's the graphic design is my passion.
Yep. And here's the sun, of course. It's a really relatively
Why are you drawing the sun away from the sun?
Oh. It's projecting itself. It's
Okay.
exuding. It's being,
Yeah.
I made the comment worse. So during the cruise phase, they started calibrating the cameras, and they discovered that it was out of focus.
Oh, no.
So actually, there's a period of the cruise phase called the bakeout. You know what that is?
Is that where they, get together, fire up the grill, have flip burgers in the backyard?
That's the cookout.
Or, that's a cookout, okay.
This is the bakeout. So pretty much it's the spacecraft will be heated by the sun, so if there's any gases caught in it, they'll just bake out.
Oh,
They'll evaporate out.
cool.
That's how they usually, they wait for that. And pretty much the solution for this is called deconvolution. They made a software patch and said, stop doing this. So on April 25th, Deep Impact takes a picture of its target.
Oh,
This is Temple 1.
that's the hit list.
There it is. I see you. So this is Temple 1, 9P Temple 1. It's kind of big. It's about 7.6 by 4.9 kilometers across, so 4.7 to 3 miles in size. It's a decent sized comet, not asteroid. It's a comet.
Yeah, that's a nice, small town sized comet.
We know how much it weighs. It's about 7.5 times 10 to the 13th kilograms, or about 16.5 times 10 to the 13 pounds.
That's helpful.
Wait, how many tons is that? Let me do some quick math. 7.5 times 10 to the 13th. I have my calculator with me.
I think that's like 165 quadrillion tons? Or, no.
Oh, yeah, that's really bad.
165 trillion tons.
It weighs a lot.
Yeah.
My calculator's still giving me an exponent. So it's big. Again, 4 miles, potato. It's a pretty big guy.
Yeah.
Its orbit is 4.757 by 1.545 AU, so it's 1.5 times the distance from the Earth to the Sun at its closest, and it's out like nearly 5 AU out. Actually,
So it's basically between Mars and Jupiter.
Yeah. Actually, it did a close flyby of Jupiter recently, this year. Its orbit changed by a lot. Because
I imagine that would do that.
It's going to hit us. Deep Impact 2.
Oh no.
Yeah, revenge. You hit me, I'll hit you. So its orbit's about 5.6 years, and it actually has a slow rotation of about 41 hours.
Really?
This is all observed on the ground, too.
Oh.
Yeah.
How do they find that out?
You look, so if it's rotating, and since it's a comet, it's kind of lumpy, and the surface is a bit different.
Mm-hmm.
So you just find a bright spot on it and just see if it moves.
Oh. Okay.
The brightness changes.
Huh.
You'd be surprised how much astronomy is done by that.
Okay.
It's how we find planets. We look at a star, and if it dims a little bit, either it's flaring or there's a planet there.
Nice.
So, Tempel was discovered on April 3rd, 1867 by astronomer Wilhelm Tempel. It's a Jupiter family comet. It's the target. It's there. It was selected because it'd be the right place for the mission for a low energy transfer, as you saw by the orbital diagram. Ease of access, it's easy to get to, and it's in a good spot so we can see it when we hit it.
Okay.
The timing of the impact is so that Deep Impact is talking to 2 stations on the Deep Space Network.
Okay.
Goldstone and Canberra. So Canberra is in Australia, Goldstone's in California, right?
Okay, so it's over the Pacific.
Yeah. It's in between them. And actually, they're going to do some observations from Keck in Hawaii, because it's in the middle.
Yeah.
And pretty much everything's looking at this thing. As it's gonna, it's like, you guys, check this out. Right? Everyone's got their phones out. It's gonna, let's watch this fight go down.
Yeah.
So, from May 5th to July 3rd, Deep Impact is on the approach phase of the mission, tracking and observing its target. Right? It knows where it is. It's getting closer. So now you can figure out how close you're gonna get.
Mm-hmm.
So it actually observes 2 big outbursts from the comet.
Mm.
So it's going, oh God, you're gonna hit me! No!
It starts crying.
It's chaff to distract the radar, right? Countermeasures. The second one's actually 6 times as powerful as the first. So these are pretty much the outbursts are sudden increases in the size of the comet's coma due to more ice and dust being emitted from the nucleus.
Okay.
And what they show is double the amounts of water vapor and carbon dioxide in the coma.
Oh. Okay.
So then a TCM or 2 are fired to get Deep Impact and, to hit.
Right.
Now we're going to get you. So, impact phase begins on June 29th. The impactor separates on July 3rd at midnight Eastern Daylight Time, set for an impact at nearly midnight on Pacific Time.
Okay.
On July 4th. Pretty much midnight July 4th. Right?
Right.
This is actually a picture of the impactor after it's separated from the camera.
Okay.
So this is it. Wave goodbye to it.
Good luck. Just go at it real fast.
Yep. So, it's going to hit the comet at 23,000 miles an hour. The impact force will be about 19 gigajoules. 4.5 tons of TNT. Or a mosquito hitting a 767. Not that
That's
much. Again, this thing weighs how many billion tons? The impactor weighs how many not tons?
Yeah.
Right? It's just going to hit it. So, here's what's going to happen. This is time moving forward, just for reference. Okay?
Okay.
So, you have the flyby spacecraft and the impactor are separated a day before impact.
Mm-hmm.
The flyby spacecraft will maneuver so it doesn't hit.
Right.
And set itself up so it can take pictures and do a close flyby 14 minutes after the impact. So it'll take pictures. So as it comes in, it'll talk, of course, to the impactor, because it's going to be taking pictures, by the way.
Mm-hmm.
On the way in, the impactor will maneuver itself up close to hit the comet. The flyby will then take pictures up to a certain point. It'll see the impact, and then it'll turn away so the dust doesn't hit it. And then after it does a closest approach, it'll turn back and take more pictures.
Okay.
That makes sense? We're all good?
Yep.
Awesome.
Yep.
And of
This
course,
diagram makes sense.
and of course, the ground is going to listen to all this and go, come on, guys, come on, do it.
Yeah.
So, this is Temple 1 from the impactor.
Oh, wow.
So you can see of course, it's all pixelated, because I don't know why it's all pixelated.
Well, it was the great pixel shortage of 2005.
So this is it on approach. So now where do you think they're going to hit? So look at the right-hand image. Where do you think they're going to hit it?
I think the bright spot.
Which side? So here I'm in the middle, kind of circling the equator. It'd be north or south?
Okay, from that mark you have.
Yep.
It'd be up a little bit. Up a little bit more.
Up.
See that little
That guy?
dark. Yeah, there.
You're
Right
wrong.
there.
You're completely wrong. Also,
Oh.
does this look like a smiley face? Like a really creepy smiley face? And like teeth?
Yeah,
You
yeah.
see, right?
I see that. Yeah.
Yeah. Remember, this thing's like 4 miles wide, right? Kind of a potato or a booger, I guess.
Yeah.
They're actually going to hit over here.
Oh, okay.
Right? It's just the way the flyby is set up, but... So, here we come.
Oh, okay.
Again, these are from the impactor. Someone
my
actually interlaced
gosh.
these and made a video of it, too, you can find.
Oh,
So they're actually
nice.
going to hit right about there, right? So here it comes. Here it comes right there, and...
Oh my gosh.
And impact.
Whoa.
They hit the comet.
They hit it.
So this is the flyby vehicles coming in, right? So you can see where they hit there,
Yeah.
and it's just dumping stuff off of it.
Oh, wow.
Look at that.
That is wow.
Look at all that dust you gotta count.
So much dust.
Yeah, just look at that.
So bright.
It's a hit. It's an impact.
Dang.
Yeah. So this is what the Hubble sees
Jeez.
in infrared, I think, right? So there's
Yeah.
the comet. Uh-oh. Impact.
Oh, no.
Look at that.
Wow.
So let's talk about some science then.
Okay.
So this impactor hits at an angle between 20 to 36 degrees, generating a crater about 150 meters across and 30 deep. So it's 500 feet wide and 100 deep. So there was a lot of speculation on what this thing would actually do on impact.
Uh-huh.
Some would say, yeah, it's going to bounce off, right? It's a solid chunk of ice, whatever. It's going to bounce off. Others say destroy the whole thing. It's just it's a fluffy ball of water ice, right?
Yeah, it's
Could be
basically
that.
snow. Yeah.
Some say that, okay, the impact crater will be either, the size of a 2-bedroom apartment, like where you're living, or the size of the Colosseum. This made an impact crater the size of the Colosseum,
Jeez.
right? So this thing generates 10,000 to 20,000 tons of debris and dust, right?
Gosh.
Look at all of that coming off of this thing,
Yeah.
right? The plume escapes between 5 to 8 kilometers a second, depending on how you map it and how you model the comet.
Mm-hmm.
The particles are less than 10 micrometers in diameter. They're really tiny. It's dust.
Yeah.
Right?
So it's less than a centimeter in diameter. Yeah.
Yeah. It's really small. The plume remains connected to the surface for hours. You gotta remember this thing. It weighs like 7 quintillion tons, but Earth weighs a lot more than that.
Yeah.
So it's called a gravity crater. Because again, another theory was that the impact would just pass through the comet. Because again, is it loose snow? What is this thing?
Mm-hmm. Mm-hmm.
The dust trajectories, because you can model and map that, estimate the surface gravity to be about 0.05 centimeters per second, or 0.000051 G.
Jeez. So that's what, 1/20,000th of a G?
Yeah. Not
Wow.
that much.
Ain't much pulling it down.
Yeah. This is one of those things you can sneeze to orbit, I think.
Yeah.
So we can also estimate the density of Temple 1 based off the impact. It's about 0.6 grams per cubic centimeter. Water is 1.
Right.
So this thing's less dense than water. It's very porous. It's actually like 60% empty space.
Really?
So they describe it as like a bank of fluffy snow.
Oh, wow. Okay.
Yeah, really wispy, and it doesn't look good, but it weighs 7 quintillion tons.
Yeah. It's a 165 trillion ton snowman.
Yeah. Yeah, that you hit at 23,000 miles an hour.
With a copper bullet.
Yeah, who shot it? So the water composition of the plume, which we'll look at, suggests that ice is not on the surface, but slightly beneath it.
So what's on the surface then?
Dust and dirt and stuff.
Okay.
Bronze Age civilizations, just our luck, right?
Yeah.
So they also suggest, because of this impact, that the nucleus core, right, the very center of it, has been unchanged since the beginning of the solar system.
Oh, wow.
So this is why we got to send up Bruce Willis and Ben Affleck to go drill in there. You're talking, water ice and dirt and dust that's 4.5 billion years old that's never been touched.
Dang. Yes. Oh, the ice cores in Antarctica. Oh, they can tell us 2 million years of history. This could tell you 4.5 billion.
Yeah.
Oh,
So
wow.
This is from that slideshow. Of course, you can't look at it, right? So the green line is the nucleus based on observations beforehand, right? So it's okay. So wavelengths, of course, are different elements, and the radiance is how bright they are, right? So the model predicts at an impact, you'll see a spike in water, which you see here in the red, and then you see a spike of CO2 because there's a bunch of CO2 ice in comets. We saw this with Halley's comet back with the fleet.
Right.
But you also see hydrocarbons.
Wait a second.
Yeah.
Why are there hydrocarbons there?
Hydrocarbons, that's cyanide. There's a few others you'll see, right? So you can see this other chart kind of talks about the different ones. You got ammonia, hydrides, silicon dioxide, silicates, right? It's got dirt and regolith maybe, right?
Yeah.
CH3CN. Oh, it's like methyl acetate. I think that's what it is.
Okay.
I looked it up because I was
All right.
methyl cyanide, right? C2H2. That's ethylene.
Okay.
That sounds about right. Yeah. So a comet is a ball of ice.
Wow.
A lot more dirt and dust than initially thought.
Yeah.
Just to confirm what we saw with Comet Halley, and then do we know that a comet flyby in this? We done that?
Yes, I think we have.
Oh, ISE-3 did. Yeah, they did.
Yes.
Jacobini-Zinner. Yeah. So this is a thermal map of the comet, just for reference, before we hit it. So you can see the side that's facing the sun's the hottest at about 330 Kelvin, which is about 100 centigrade.
Okay, so that's like 200
Fahrenheit-ish.
Fahrenheit.
Yeah,
Yeah.
and
It's
the-
very, very warm.
And the backside, and this is the surface temperatures, right?
Right.
And the
Yeah.
backside, the dark side, of course, is about room temperature. 260 Kelvin's like, what?
That's negative 15 Celsius. That's about freezing.
That's pretty chilly.
Yeah.
Yeah.
So it's freezing on one side and then baking on the other.
Yeah. You can see the context image, of course, in the bottom right.
Yeah. The bright spot is the one that's...
Yeah. Who cares about thermal science? We hit that thing.
Yeah. What did the thermal science say about that,
Yeah.
huh?
We did a lot of thermal science with that.
Yeah.
So this image, there's a bunch of outreach, including several amateur and student astronomy groups. They actually take pictures of the comet before, during, and after the impact. This is one of them. And you can by Italians. So I don't know what you want to make of that. There's a lot of public outreach. I think there was in Hawaii at a beach. They actually had a beach party. Like actual musicians showed up to it and played music as images were coming in for the impact. Yeah. The Chinese take note of this actually, and they say there's a lot of public outreach in all of this. Maybe we should do more of that with our space program so people know what we're doing.
Mm.
So they actually do plan their own comet redirect mission, which still has never happened. But they started off with moon missions, which they've been doing.
Hey, nice. Good for them.
But here's the most important thing, though.
What?
A Russian astrologer sued NASA for $300 million for this. Her name's Maria.
Why?
This thing upturned the balance of forces in the universe. It's messing the whole thing up.
He killed the vibes?
Killed the vibes.
Punched the vibes in the face with with a copper bullet.
At 23,000 miles an hour.
Yeah.
Sorry, what was that? Fun fact, $330 million is how much the mission cost.
Okay.
So it's double the mission cost. That's what they're being sued for, NASA. Now, once the lawsuit actually started progressing beyond weird, silly claims, the lawyer was saying, your cell phones, did they work that day? I bet not. Magnetic fields were interrupted somehow.
How? How to be interrupted?
Exactly. So you can see how far that lawsuit went.
Yeah. It got to the judge. The judge says, what?
Yeah.
No.
What are you guys doing? Yeah, my cell phone works. The balance of the universe is fine.
The vibes seem chill, right?
I guess. I don't know.
They had music going on the beach when the images were coming in, so seems like pretty good vibes.
There we go. So the original end of mission was planned for 30 days after the impact because it was supposed to be a year or so in space, so August 05. But here's the thing. It only launched like 6 months earlier. It's a spry, fresh, young spacecraft ready to do spaceship things. What could you do?
Maybe send it to somewhere else in the asteroid belt, take some more images?
Huh. Interesting, isn't that?
Yeah.
So it gets 2 new jobs, okay?
Okay.
One's called, it's called Epoxy. So the first one is called Epoch, Extrasolar Planets Observation. They got a nice camera. They can take pictures of things with this. I couldn't find anything on this part of the mission.
Great.
So it's pretty much, so it did help discover 2 discoveries, 2 planets, extrasolar planets,
Okay.
like hot Neptunes, I think.
Around some other stars,
Yeah.
just like chilling or I guess baking.
Yeah, hot Neptunes in your area, you know.
Yeah.
So they also did. So it's gonna do some flybys because it's gonna try to do another comet encounter, right? They're not gonna hit it though this time. I mean,
Right. They already dumped the impactor.
So it'll do Earth flybys and it'll observe Earth for signs of life, because as we're all kind of doing, it's like, okay, we're looking for life around other planets. What does that look like?
Can it actually find life around Earth?
Yeah, they all make that joke. Hey, Earth's got life. Every time they do a flyby, Juice did a flyby of Earth last month. They said, look, we found life on Earth. Ha ha ha. And then everyone's saying, but is it intelligent?
No.
Not anymore, it isn't. I'm get sued by a Russian psychic. Jeez.
Yeah, you just threw the whole entire vibes off.
Yeah. I'll fire another one at you. So the other one's called the Deep Impact Extended Investigations. That sounds like a Private Eye from like a sci-fi thing.
Yeah, it feels like the X-Files offshoot series.
I've been watching the X-Files actually. It's a fun show.
Yeah.
It is. It's really good. So on 21st of July, so the extended observations are go fly by more comets. You can take pictures of comets. Just don't hit them this time, guys. Okay?
Still has that thirst for blood though.
Yeah.
It got the high and the thrill the first time.
Gotta do it again. Come on, let's do this. Yeah, let's do it. Yeah. So it's gonna set up for its first one will be Comet 85P Bothan. I don't know how to pronounce it.
Bothan. Yeah, probably.
So it does a trajectory correction maneuver in pretty much like 20 days after it, right? It's hit and run, right? Hit, get out, go, right? Or this be a drive-by, right?
Yeah, drive-by.
You shoot at the comet, keep going, right?
Yeah.
So they set themselves up for an Earth flyby, they set themselves up to do a flyby of Bothan in December 2008. Except during the flyby, they lost the comet.
They lost it?
Yes.
How did you lose it?
It was there and then it wasn't. So either the equipment wasn't good or the comet just broke apart.
Just because?
Yeah, I don't want to get
Did
it,
it
guys.
threaten it on the...
You saw what happened to the other guy, right?
Yeah.
This place is
Don't want to mess
crazy.
with it. It just zoop, deletes itself out of reality.
Yeah, it most likely just broke up. The band broke up, one-hit wonder. I mean, no, the Deep Impact's a one-hit wonder.
Yeah.
That's the name of the episode, isn't it? So they're sending it instead to 103P Hartley 2. So they start on November 1st, 2007, which will have 3 Earth flybys. So these will be the flybys where it looks for intelligent life on Earth and finds people making puns and Russian astrologers.
Yeah.
This is the mission track for that, right? Where they, TCMs, there you go. Earth encounters, and it's going to take pictures of Hartley. So this is a picture of the moon taken on one of the flybys. Because again, they're looking for life. How do you look for life with a spaceship?
Yeah.
So this is the moon.
You point the camera at it.
You take pictures, and if they give you the peace sign, it's good. If they don't give you the peace sign, it's not good. Bad neighborhood. Right. So moon,
And then you send the impactor at it.
yeah. Okay, is this a deep space one or is this a deep impact?
Yeah.
So this is the moon. It's flying over the North Pole of the moon. As you can see, right there's the craters.
Mm-hmm. Yep,
So
there's the mares.
Yeah, the mayor. Yeah, why the mayors? I didn't vote for him. That's a joke. You're gonna deep impact me now.
Yeah. I know where you live.
Yeah. So it does a temperature map of the surface of the moon. You notice the surface of the moon's kind of hot.
Yeah, it's baking a little bit.
When we do the Apollo missions, we'll talk about this in terms of mission planning. Because they were planned to be, the landings were before noon on the moon. So it's like the mid-morning on the moon.
Okay.
Because you don't want the surface to be too cold after the lunar night, because you'll still want visibility, right, all that. But you don't want to be too late in the lunar day, because you'll be baked in the suits.
Yeah. Yeah.
But you'll see it also finds water signatures.
Ooh.
Not in the hot spot, but in the cold spots up at the poles. Huh.
Yeah, I wonder why.
Yeah, weird, kooky.
Yeah. Almost like they're, the craters up there are left in darkness.
Yeah. Interesting, right? Yeah.
Yeah.
Let's go to Hartley, the interesting thing. Okay, so this is Hartley 2. Take a look at that
Ooh,
guy.
Cool.
Yeah, that's a comet.
Yeah.
Look at that thing. So, Hartley is noticeably smaller than Temple 1. It's 1.2 by 2.25 kilometers. It's about 3/4 of a mile. It's about 1.5 miles across, right?
Okay.
It's like a potato or a peanut.
Yeah. I can see the kind of the peanut shape. It's smooth, kind of in the middle.
We'll talk about why it does that. We actually know why.
Ooh,
What do you think does it?
Oh, it's because the two big rocks came together, and then they shared the sand, giving it that hourglass shape.
No.
No? Oh, okay.
You got anorexia.
Ah.
Yeah. So the orbit of comet Hartley 2 is 1 AU by 5.9 AU. So it orbits the sun every 6.5 years, and it stays about 18 hours.
So it's going a little quicker than
Yeah, the young whippersnappers,
Yeah.
I got shot right hit by these humans. It's like, oh gosh, going for the little prey now. So this was just what?
No, nothing.
Oh, okay. You're gonna make a joke. I
Yeah.
don't want to ruin your vibe.
No, you're good.
Okay, good.
I'm going to sue you for $330 million.
Yeah, set up the vibes of this.
Yeah.
So this was discovered by Malcolm Hartley in 1986. It's shaped like a bowling pin or a peanut.
Mm-hmm.
Again, it was within range. You could fly by. You could get close to it. It's a comet.
Yeah.
So Deep Impact flies by the comet on November 4th, 2010. So that's about 14 years ago to the people listening in December.
Yeah, a little over.
Yeah. The images are actually so good, as you can see here with all the pixels, that you can actually see different jets coming off the comet, right? You can see them. I have more pictures, don't worry.
Okay, good.
And the interesting thing, though, is the jets are coming off the dark side of the comet.
Ooh.
Now, the middle section is actually dust from the jets. It was moving so slowly, it just collects in the middle.
Oh,
That's what does it.
Ah.
Now, what do you think makes the jets? What do you think the jets are made of, and what makes them?
Well, I would assume that you have surface heating from the sun, and then when it gets the dark side, it cools off. But how would it erupt?
Well, what's causing the eruptions, though?
It has to be heated internally, right?
Yeah.
So it basically warms up during the day?
Yeah. Well, and we're talking about the specific mechanisms. Because, I'll just tell you, the jets are actually carbon dioxide. The particles are water.
Oh.
Yeah, so that's carbon dioxide pushing water off.
Oh.
Yeah, because remember, carbon dioxide boils at lower temperatures than water. Because remember we got dry ice that one time when I was trying to make a cloud chamber?
Yeah.
That was gone within a few days.
Yeah.
Water doesn't do that because it's water.
Right. It melts and turns to water.
And so some of the water chunks coming off are the size of golf balls or basketballs.
Wow. So that's pretty big chunks.
Yeah, and so what it looks like is going on. It's a water ice surface with dust and things. Then there's CO2 ice beneath that, and that heats up faster than the water, or it boils faster because it's
right,
and it pushes it out.
Huh.
Breaks on out.
Dang.
That's how comets work.
Never knew that until just now.
We'll learn about this more when we talk about Deep Impact, the movie.
Ah. Okay.
Because Jon Favreau gets it because of one of those.
Whoops.
So then, this is Hartley 2's surface, and so these boulders are like a few hundred feet across.
Just really big
These
boulders.
are really big boulders, but you can see there's jets there, and it's all dust around it too, right? It's going 400 miles away, but it's still just kicking off dust and jets.
Yeah.
Isn't that cool?
That is amazing.
You can see, and this is another image of that, of course, and the different jets coming off of it.
Wow.
And then you get a good reference point. This also looks like a Q-tip.
Yeah, it does.
Yeah.
It's kind of elongated, got those boulders on the outside, shooting off jets.
Yeah, it's a Q-tip. You can see, but that's a comet, and it's making jets, and you can see them.
Yeah.
So cool.
That is awesome.
After we hit one, I mean,
yeah.
we're learning a lot about comets on this mission.
Oh, yeah.
We're going to hit them, we're going to take pictures of the other one.
Yeah.
So these are, again, more spectroscopy from Hartley. So you'll see in the spectrograph, so one of these was colored in the other one, but not very well.
Mm-hmm.
So I did the slide format. You can't really tell the difference, but there's two regions that we're looking at. H2O.
I can tell the difference. I can see the difference in the color.
Okay. So one of them is the water vapor outflows. You can see a bunch of that. Then you have the jet regions of CO2, which are like the more fuzzy ones, I guess.
Mm-hmm.
Water is but you can see for some of these, there's ice in the radiance, right? It's absorbing some of the light. And you can see organics.
Yeah.
Of course, organics in this sense mean just hydrocarbons.
Right.
Carbon stuff. Yeah.
We found life.
Another Bronze Age civilization.
Yeah.
Guys, we keep finding these. Stop shooting them.
Shoot them faster.
Yeah. All right. So, after the flyby of Hartley, Deep Impact's kind of puttered out, right? This is 2010 we're talking about. It's been in space for 5 years. It's it's like it's cooling down, right? My blood thirst is kind of low.
Yeah.
But maybe you could do another an asteroid flyby, right?
Yeah.
Get yourself one last hit, I guess.
Yeah.
So this target is 2002 GT. It's a really small asteroid. It's 350 to 500 meters across. It's about 1,200 to 1,600 feet.
So it's like the size of a stadium.
Yeah. It's the size of the impact crater that they made.
Yeah.
It seemed bigger. Yeah. So the flyby would be targeted on January 4th, 2020.
Wow.
So
a long way away.
Yeah. So Deep Impact does two burns on November 24th, 2011 and October 4th, 2012 to set up the flyby.
Okay.
In 2013, Deep Impact actually observes Comet Ison. That was a really big comet everyone was looking at back in 2013, if you remember that.
I don't.
I don't either. So I kind of remember hearing about it because this is when I started really getting interested in space and space flight.
Okay.
So, yeah. But it doesn't do a flyby of 2002 GT.
Oh.
So between 11th and August 14th, so August 11th and 14th, they lose contact with the spacecraft. And this is 2013, so 10 years ago. What they discover is that the systems are constantly rebooting.
Why?
Don't know. Well, there's a theory as to why. We'll talk about that in a second. The problem with that is, if they're constantly rebooting, how do you know the antenna is pointing at Earth?
You can't.
Right? How you
don't
signal
know.
lock. And how do you make sure the solar panel's pointed at the sun?
Ooh, you can't.
Yeah. So the theory is that this thing had a unsigned 32-bit integer overflow. So it's kind of like the Y2K or the year 2038 problem. Because, so spacecraft time is measured in like tenths of a second.
Okay.
And a 32-bit integer is like 2 to the 34 bits. And right around there is when it hit the size of that integer.
Okay.
So pretty much it just said, oh, okay, back to 0. Or just didn't know what to do with it.
Oh.
And so it started going, well, gotta reboot. Oh gosh, what's going on? Oh no.
So basically the spacecraft got dementia.
Yeah, it got Alzheimer's. So in 20th September 2013, end of mission is declared. Deep impact is no more. Maybe the comet got it.
Yeah.
Temple 1, this is Comet Tony, Yeah. Yeah, I'll give you a 32-bit unsigned integer overflow. Okay, come over here,
You hit my asteroid, you hit Temple 1, I'll give you Alzheimer's.
Yep, you're gonna get Alzheimer's now, buddy. So, this isn't the end, really, of Deep Impact, the mission. The spacecraft is dead. But
right.
We have still other spacecraft. So here's another Discovery-class mission called Stardust.
Okay.
Which does a comet sample return, which is really cool. We'll talk about that in, I think, 2026.
Okay.
But, again, that spacecraft does an Earth flyby after it dumps off its samples, and it's still working. Mm-hmm. Now what do you do with it? Let's go back to the scene of the crime.
Now we got the cops.
So this actually happens in around the same time they do the Hartley flyby.
Oh,
they do like three.
Okay.
There's like 2 comet flybys within 3 months of each other. I think it's this one. So this is Stardust. It's a little guy mission. Again, Delta 2. We'll talk about it in the future. But it returns to Temple 1. Whoa. So this is the image taken by Deep Impact, right? The impact is down here between these 2 big craters. And you see this kind of like glacier tongue thing, right?
Yeah.
So this is what Stardust sees on its flyby. So the impact crater is right there. You can see it,
Wow.
right? But this is up close of it. So this is what Deep Impact saw, right? So you can see the shiny bit of the tongue there, right?
Yeah.
It's whiter. And you got 3-ish craters here in a row.
Mm-hmm.
Now if you look at it, it's not as bright. The white spot is not as bright.
Yeah, it's very dim.
And the craters over here are filled in with dust from the impact.
Could it just rain the dust down down on
We should do another comet impact mission like this. We put a lander or 2 on it, right?
Yeah.
Do seismic stuff so you can see what's the inside of it.
Yeah.
As the sound waves go through and back and forward. But yeah. Yeah, so we shot a comet, and then we returned to the scene of the crime with a buddy.
It's like, well, let's see what happened. But also I could see, like, with the other features between the 2 comparisons, you can see that it's the first image that Deep Impact took was very sharp. Like, all the features are very sharp. But with Stardust, it looks very fuzzy because of all the dust.
Yeah, because a lot of it was just kind of held to it, weakly bound by gravity, and eventually just come back down. Now, some of it was blown away by the sun, right?
Yeah.
You're moving at 8 kilometers a second, where your surface gravity is a sneeze away, right?
Yeah.
So it's going to get blown away. But we hit a comet.
Yeah.
Take that. So the other impact of this mission is we did another impact a couple years ago called DART.
Oh, yeah.
Where we smacked a spacecraft into an asteroid moon. And this is a picture. There's a CubeSat that took pictures of the impact. This is like a cube. Yeah. So we did it again. We will do that. We'll do that mission when the Hera mission, which just launched this week, will go there in 2026.
Okay.
We'll do kind of a follow-up because we don't have any pictures of what happened to this little asteroid moon after we hit it. I mean, they look like this, or Hubble images, stuff like that.
Right. Very fuzzy images.
Yeah. The Hera will actually get up close and take pictures of the site.
Going back to the scene of the crime.
Yeah, another droid. Yeah. We keep hitting these things. We do hit jobs,
Yeah.
So that is Deep Impact.
Wow.
A fun little mission blowing stuff up. You can see the relative sizes, of course, of Temple 1 and Hartley 2.
Yeah. Hartley 2 is a lot smaller.
Yeah. And it's out. And again, we learned a lot about comets today, didn't we?
Yeah. How it's the carbon dioxide that's shoving the water out. That's
Yeah.
causing the jets.
That's really, again, it's so cool. And we can learn more about the primordial solar system from these missions.
Yeah, we sent Bruce Willis down there,
Yeah.
right? Collect some ice samples, some ice cores from these asteroids, right? And these comets, excuse me. Right? We'll bring it back.
Yeah. Actually, there was a mission that was proposed as a follow-on to Rosetta called, I think, Caesar or Corsair, where they'd actually land on a comet and take samples.
Ooh, that'd be cool.
It was not selected, just to be clear.
Dang it.
We should do an episode on like missions that didn't happen.
That'd be kind of fun.
Yeah, different mission proposals like Discovery class, Flagship class, those. Because there's a whole bunch of them that are pretty interesting.
Yeah.
Yeah.
Just look at that, though.
Oh, yeah. And the pictures of the comet, like, getting hit. I'll show you the video of it. Because it's, like, interlaced. So they interlaced all the images that were taken by the flyby probe. It is so cool.
Because I remember because I'm pretty sure I watched DART live, and I saw the images coming in live.
Oh, yeah. I did, too. That was so cool. 'Cause
Yeah.
it's just, oh, there it is. There it is. Even closer. And then...
Yep, and then there's like the top third of the image, and that's it.
Yep. So that's Deep Impact. A hit and run.
Got the thirst for blood.
Yep, got the thirst for blood. NASA's thirst for blood has not stopped. We're doing it again. We did it again. We're going to go back to the scene of the crime. Oh, jeez.
We're gonna do it a third time.
Yep, we'll do it again.
We can't be stopped.
Yeah.
We will end all of these Bronze Age civilizations
On asteroids.
out of these snowballs.
Yeah. Yep, so that's Deep Impact. Any other thoughts you have on it?
Very cool.
It's a very cool mission.
Yeah.
Very cool. So the next mission, the first one of 2025, is going to be STS-61B.
Awesome.
Yep. We're going to talk about tortillas and building stuff in space.
Ooh, fun.
It'll be a fun mission. Also, the second to last flight of the shuttle program before Challenger. So,
Oh,
yeah. Whoops.
great.
Yeah.
Okay.
Yeah. So that was Deep Impact. Oh, and just for a custodial note here, I think and I hope I fixed the sound issue. See, my problem is I move my head around when I talk,
Mm-hmm.
so my audio changes as a result of this. I learned this when I was editing. All the audio issues are mine and mine alone. Okay. I'm a structures engineer, not an audio engineer.
See, you could build a structure, just like keep your head in place for the proper audio.
Yeah.
You could do that.
It looked like one of those saw traps, though. That's the problem.
Yeah, just build a saw trap for yourself. That'll give you good
Merry
audio.
Christmas, everyone. Actually, this will be early December. We'll do Deep Impact the movie. Christmas. Again, this is October. It's not even Halloween yet.
Yeah.
Getting ahead of schedule. Oh, since this is the end of the year, sort of. So next year, 2025, we're going to have a lot more episodes. We're going to try to get one every 3 weeks, with the goal of hitting one every 2 weeks in 2026.
Yeah, we're gearing up.
Yeah. And luckily, we haven't learned anything from something that happened 40 years ago that also tried to gear up to that many episodes a year.
Look, history is meant to be forgotten, all right?
Yeah.
That's why we give our spacecraft Alzheimer's.
Learning is for nerds. Shoot comets.
Yeah.
All right. Yeah, so see you in 2 weeks for Deep Impact the movie, where we can talk about how realistic the movie is now.
Yeah. Finally.
Yep.
All right, well, this has been End of Mission.